This is a flip video about energy calculations. So we've already done a little bit about energy, wavelength, and frequency. So now this video is about how to actually do some calculations to get values of energy, wavelength, and frequency. So let's start off with some basic things that you should know. And that is, the symbol for wavelength is this right here. It's an upside down Y called lambda, Greek alphabet. And the symbol for frequency is kind of like a cursive or a slanted italicized V. Some other important things to know are some units that we will be using. So we're going to be calculating energy. So the unit for energy is J, which stands for joules. The unit for wavelength and frequency are seen here. Wavelength usually is measured in nanometers, but sometimes we get meters. Frequency is measured in a 1 over a second or a second minus 1, kind of like what you do in math when you take a fraction and just turn it into a regular format, we'll call it. Or hertz, HZ. These are the three different types of units for frequency. Okay? Now, if you noticed, I talked about a nanometer and a meter for wavelength. So it's important to know the conversion between the two. A nanometer is a very small unit. So in 1 meter, there's 10 to the 9th nanometers. That's important for us to know as well. Okay, now, how do these variables all relate to each other? Well, there's many different equations. So here's the energy equation. Remember, E stands for energy, and the equation is E equals H times this cursive V. Remember, that cursive V stands for frequency. Okay, so H times frequency. Well, what's H? H is known as Planck's constant. So let's write that down. This constant will be given to you. You do not need to memorize it. 6.626 times 10 to the negative 34th. Now take a look at this unit. This is a joule times a second. Joule times a second. That's a constant that will be given to you. So E is equal to Planck's constant times frequency. Okay, that's one equation. And our second equation we're going to use involves the speed of light, and that is the speed of light is equal to lambda, which is wavelength, times frequency. The speed of light is given the letter c, and it's also a constant that will be given to you, and that's 3.00 times 10 to the 8th meters over seconds, meter per second. Okay, now that we have these important conversions, equations, and units, let's actually solve for a problem. This problem says, calculate the frequency of the orange light seen in lab. So we saw some orange flames, and the wavelength is 570 nanometers. And if you notice in this problem, they gave us our wavelength in nanometers and in meters. So let's see our equations and what we're going to do. So we're given wavelength, only wavelength. So I look at my problems, or my equations, and I say this one has wavelength in it, and they want us to calculate the frequency. So they want us to calculate for this. Well, I know that speed of light is this value here, so I can rearrange my equation. So let's do that now. Here's my equation. And I'm solving for frequency. That's frequency. So it's kind of like solving for x. Get it all by itself, which means I divide by wavelength. Wavelength and wavelength cancel out. Whatever I do on one side, I do on the other. So now I know, let's rewrite the equation. Frequency is equal to speed of light over wavelength. So now all I have to do is solve. So let's go ahead and do that. Plug it in. Frequency is equal to, here's my speed of light, 3.00 times 10 to the 8 meters over seconds. Don't forget your units. And wavelength. Now, should I use the nanometer or the meter? Hopefully you said the meter, because meter and meter will match up. So I look at whatever's given in the problem and try to match my units so they cancel out. So times 10 to the negative 7 meters. Okay, good. Remember, meter and the meter will cancel out. So when I divide these, So this is a good time to divide them right now in your calculator. You will get a unit that is 1 over a second. Why? Because when the meter on top of seconds gets canceled out, it's left with a 1 on top over seconds. So that will be my unit. Okay? Remember, we don't look at any constants for sig figs. So I look here at 1, 2, 3 sig figs. So my answer should have 3 sig figs. Please take this time and put this in your calculator and get an answer and write it down. Okay, next, this is the last problem. What is the energy associated with red light at 750 nanometers? Okay, so let's bring back my equation. This is the energy, and they want us to solve for energy. Here's the equation. But they only give us wavelength. Okay, so we're given wavelength. Always find what you're given, circle it in the problem. You're given wavelength. The energy equation doesn't have wavelength. So I'm going to have to use both equations together. I know that if I use this equation, I have the wavelength, seen here. I always have speed of light, it's a constant. I can then get the frequency. When I get this frequency, I can plug it in to my second equation. I know h is Planck's constant, so now I can solve for energy. So let's begin. So as I just said, I know speed of light, I know wavelength, and I could solve, oops, that's a times, I could solve for frequency. So let's begin. I'm going to solve for frequency. Again, speed of light was given to me over my wavelength, which is here. Uh-oh, I have an issue. My wavelength is in nanometers. So I have to first take my nanometers, 750 nanometers, and convert to meters. Remember that conversion? 1 meter is equal to 10 to the 9th nanometer. Okay? And it's a good time to put this in our calculator, and hopefully you get 7.50 times 10 to the negative 7. Check that and see if it matches up. If it does, then you know how to use your calculator. So I'm going to plug that in here where it says wavelength, 7.50 times 10 to the negative 7 meters. I did that so my units can cancel out. Very necessary. So now I get an answer here. So solve and get an answer, and it's 1 over a second. Okay? All right, next. This answer is my frequency. Remember, I solved for V. I now can take that and plug it into my energy equation. Remember, my energy is H, which is Planck's constant, so let's bring that back. Planck's constant, 6.626 times 10 to the negative 34th. Don't forget your units, joules times a second. All right, times that frequency you just calculated right here goes in right there. So please calculate that and put it in. Don't forget the unit. Okay? Now my seconds here cancel out with my seconds down here. And I'm left with just joules. Okay? I don't do sig figs in a constant. So this one needed 3 sig figs. 3 sig figs. So this will have 3 sig figs here. So my answer should have 3 sig figs. So please calculate that now as well. So there's 2 steps you're going to need to calculate for.